data, the group data, if I am looking for group data, mode, median, and mean, it's still the same principle, but it's now with group data. So to find the modal class, which is the other word for mode, the mode is when you have specific data, the one that appears the most. For the modal class, it's the class interval that has the highest frequency. So that would mean my highest frequency would be in the class 62, 69. Right. To find your average or your mean, how would we find the average or mean in general? If I have 30 kids, add all the marks together, divide by 30. How do I do it if it's in class intervals? What does it mean? Because I don't even know what this represents. The sum didn't say, and it can be like this. It could have been something like the percentages of your math class. So there were 5 kids that had between 40 and 49. Fantastic, this class, nobody failed, nobody had under 40. Okay, this is also fishy because nobody had 100. Okay, well, that's just because they always wanted the intervals to be the same. If they wanted to say 100, they could have, because of the nature of this situation. But they went to 49, so the 50s are in this one. So that's to be able to say, you got an E, you've got a D, you got a C, B, and an A on your report card, an A+, if they did want to do that. But to find the average then, you cannot say how many marks these 5 kids got. They could have, all of them gotten 40, 40, 40, 40. All of them could have had 49. All of them could have had 46. Or one could have had 40, 42, 46, 40, whatever. I don't know. So the technique is we look at the class midpoint. So what's the midpoint between 40 and 49?
24.
Is it 44,5? If you really take 49, subtract 40 from it, divide it by 2, it's 44,5. But I'm just going to say 45. Is that okay?
Yes.
Okay, so the class midpoint. If they asked me, if they didn't ask me, which they didn't, you could have just gone and did the sum as we're going to now anyway. With the class midpoint being 45, you would have said, take 45 and time it with 5. Then you add, what's going to be the midpoint of this one? 55 times 8. Help me finish this up. Then it would be 65 times 9, 75 times 7, 85 times 6, and 95 times 5. Because that's every one of them. I'm estimating each of them got the class midpoint value because it's an estimated mean, an estimated average. And then that I can't put all on top of, and I don't even know what they are. What is the amount of kids that are in my class? 40. Are there 40? So if you add them all together, they give me 40. So you're going to take this whole thing, big bracket, and say divided by 40. Then you'll get your average. If you wanted to do it this way, it would have been fine. You could make your little table still here. Or I would have said, complete the following table. So give me the class midpoint, 55, 65. Please don't do both techniques because you're wasting time. Are you with me?
Yes, ma'am.
So if you've done it this way, what would you then have done? You would have said time these two together because that's what you're doing. So then it's F, and we would have said maybe that this is X. If you wanted to call it P, that's okay. Then you would have said F times X or F times P or whatever you'd like to call it, normally you call it X, and then we would have had actually the answers here, which we don't have. If you had actually the answers here, the total answer would have still been what this answer there would have been. Are you with me? That this question didn't require it, so I'm not going to do double work. But that's if I said complete the table, you better complete the table because it's worth a mark. But ma'am, I did get the answer, that's fine, but you didn't do what I asked. Complete the table. Please give me an answer. Do we have an answer for the total?
69.
Is the average 69?
Yes, ma'am.
Okay, what was the total, please? Can somebody help me? Okay, so it's irrelevant, doesn't matter. So when you type all of that in, you get an answer divided by 40, which will give you, is it exactly 69?
Yes.
No decimals. Fantastic. So that is my mean or my average. So the average for this class was 69. It's fantastic. All right, then the last thing we need to find is our, because we're talking about the measures of dispersion, of tendency, measures of tendency, which means what is the tendency of these math marks? Is it good, is it bad, looking at the median, mode, and the mean? So for the median, which we also call Q2, how would we find the median? For normal specific data, we'd line all 40 of them up, and we find the middle of the middle. Where's the middle of 40? Between 20 and 21. Now, if I actually had those two numbers, I would add them together and divide it by 2, but I'm not going to get them. I don't know where the 20th one is, but I can estimate it. And that's why I need another column here in my sum. So this was my frequency, right? I need a sum of frequencies. Why? I'm looking for the 20th and 21st data piece. So far, lining them up from the smallest to the largest, I've got 5 kids. Then I'm adding that 8 together. So far I've got 13. So do I already get to the 20th one? Not yet. So when I add 9, aha. So the 20th one and the 21st one should have been in here, between 60 and 69. Are you with me? So it's between 60 and 69, which means if I then estimate the actual middle one, what would it be? I think if you thought this way over here, you should also think the same way over there. And if you had thought 64,5, 65,5, that's what you'll answer there as well. Have a look at this. Between 60 and 69 is your mode. 69 is your average. 65 is your median. All of them kind of like line up. So I would say, without very much information, that if those tendencies seem to be kind of like the same thing, that this data set has been normally spread, which means the very least ones aren't so much, the very larger ones aren't that much, the good achievers and the bad achievers aren't that much, and the most of them sit here in the middle. That's what a normal spread actually looks like. And in maths, normally the biggest group is right here by the 40s around about. The ones that get 90s and 80%, those are the lesser ones. And hopefully also the ones that fell under 20% and there are also the lesser ones. Are you with me? Okay. So when I have discrete data that I actually can see that these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 kids got, what did we say what this was? Amount of cigarettes smoked on a day. It can be anything. Just listen to the question. Nothing given, so I'm not quite upset about what it actually represents. But if they're asking me for the range, specifically, what is the range of this data set? Maximum minus the minimum. Must you write that? No, but it's just good method. So I'll say it's 17 minus 6. Must you write that?
Yes.
Yes. Can you just write that that is equal to 9? Is it 9?
11.
If you just, okay, now say for instance, I just wrote 9 because I can't subtract. 17 minus 6 is 9. So how many marks do I have?
0.
Nothing. But at least, no, nothing. If I at least wrote 17 minus 6, I'm trying to make a point here, okay? If I at least wrote that, there's a mark to be given. 9, I'll say, what went wrong with you? But now I can give you all your marks. If you only wrote 11, do I have to give you all the marks?
No.
Yes. But this is why I'm teaching you for making mistakes. rather show me the steps. So if you did go crazy a little bit, and you wrote that the answer was 9, there's a mark to be had here, because you got the right idea, you just can't subtract. Okay, please write. They didn't ask it in this question, but what is the interquartile range? Guys, this is my own abbreviation. You actually have to write it out. But if you do abbreviate it like that, it's fine. Just don't make some other funky stuff. Interquartile range, what does that mean? Q3 minus Q1. You've got to know it. So in other words, it's the range or the distance between quartile 1 and quartile 3, which means something about the dispersion or the spread of your data. Is it widely spread to one side? We're going to be talking about skewness of data just now. How has this been spread, or is it quite symmetrically and normally spread? Which is in general what happens to most things, but that's the reason why we're doing this data handling and statistics, because we want to see the skewness and the things that are happening, tendencies that are happening in specific sums or situations. So what would be quartile 2? 1 minus 2. This is the reason why I need the 5 number summary, which is the easiest 5 marks you'll ever have, which will maybe just be 3 because we group them together, maximum and minimum 1 mark, median 1 mark, something like that maybe, but it could be 5 marks. That's the easiest thing ever. How do you do that? You count it, very technically. So with the 10 of them, where's going to be my median? Still like in the previous sum, between the 5th and the 6th. So it's going to be 5th and 6th. Does that mean 5.5? No. That's the position. There are 10 of them, so I'm looking at position 5 and position 6, and that's where my median will be. Right smack in the middle. So what would the median then be? 11,5. Because you're actually saying 11 plus 12 divided by 2. Do you have to write that? Go ahead and do it. I don't think there should be a problem. Minimum we already said was 6, the maximum was 17. That's why the range was the distance between them. Now we still need to get the interquartile range, so that's why I need the other quartiles. What does it mean if I'm taking my data and getting them into quartiles? You are dividing them into 4. You're dividing them in 4. Quarters, quartiles, or percentage-wise? 25%, 25%, 25%, 25%. Making your whole spread of how many data there is. 10 pieces, 60 pieces, I don't care. But you're taking all those pieces and dividing them into quarters. So where would the quarters then be? So basically you're taking a half of the half. Right? So now you were taught how to do that. Do you take it like this and go into the middle? Do you take it like that and go into the middle? One answer is going to be 10 and one answer is going to be 9. What did the calculator say? What did the calculator say? The brand new calculator. Punch it into your calculator. Find it because it has its own way. The calculator I think would have said 10. And 14. Because you look, there's the middle. Where's the middle of that? You see it? Now if you had done another technique, but I need to see something to give you marks for. Don't just tell me numbers here. I need to see what you've done there. Alright? So did somebody do it on the new calculator? I'm not seeing the new calculator. Right? I need it on the calculator, please. So if then I have my Q1 as 10 and my Q3 as 14, then I can go back here and answer the question. I did this because I in any case need to do it. The question was there and for the boxing whiskers. Otherwise I could have just gone over there and did the Q1 and the Q2 of 3. Quartile 1, 2, 3. Or the lower quartile is the other word, and the upper quartile. Or Q1, Q2, Q3, or the lower quartile, or the upper quartile. So do you know why they called it Q2? The median is the middle, so that's actually the halfer. But there's no such thing. They are quartiles, 1, 2, 3. So quartile 2 is actually the halfer. Are you with me? So therefore, I can now go back and say quartile 3 minus quartile 1 is 14 minus 10, which is 4. Meaning that it's not widely spread. So in other words, between quartile 1 and 2, what percentage of your data lies between quartile 1 and quartile 3? 50%. Half your data lies in between quartile 1 and 3. Focus, guys. Catch this. It's very easy, very basic. But half of your data lies between quartile 3 and quartile 1. And how wide was that spread? Only with 4 units difference. So it's very clumped together, very pressed together, all on one heap. And you can explain that to me in any language that you want to. No, not any language, in any manner that you want to. That it's all quite clumped together or quite bunched together. That's what it means. So look at the middle ones. You see that they are not very widely spread. The biggest spread was 11, which isn't wide, but it's a little bit wider than, look, because now remember that the range is all 100% of the data. It's spread in 11 digits, between 11 digits. 4 means that they're quite clumped together in the middle then. Okay, just talking about the stuff, the way that they can be asking you a little bit later. So if you have to now go and draw the box and whiskers for another 5 bonus marks, first thing you have to have a number line. You don't just draw a box and whiskers. You need a number line because you need it to be on scale. Now look at your data. You're going from 6 up to 17. So you need to at least get to 6. Maybe start at 5. Okay, maybe start at 5, 6, 7. Okay, it takes some time, but that's what you're going to get 5 marks for. Alright, make sure that you have your 17 and you have your 6. Now I need to indicate all of that on my number line. Some people draw it on the number line, please don't do that. Do it the way you're taught. So that 6 is the bottom one, but maybe sometime you'll see it in a memo or somewhere else, then you know what they did. 6 is the minimum, 17 is the maximum, and for that you just make a little line. Then you need to do the box using the 10, the 11,5 and the 14. So 10 is a big line, 11,5 is a big line, and 14 is a big line, making the box. And please do it with a ruler. And therefore you've got your 5 marks, most probably. I would like you to write on there, label it, so that you can tell me that the minimum is 6, that Q1 is 10, Q2 is 11,5, and Q3 is 14, and that's your maximum of 17. You can't go wrong. You know that they can see. Otherwise they could say, well, it looks a little bit not on top of the 10. Okay, don't overthink it as well. If I give you the sketch, don't go measure with your magnifying glass. You can see I try to make it a 10. Okay, so there's your sum done and dusted, full marks. Let's, while we are here, start thinking about, because we're going to get there again, and we'll repeat ourselves. They're going to talk about this spread, because this is now what it's all about. Does it mean that there's more data lying over here? No. Guys, focus. I want you to get this forever. Does it mean that this longer piece here means that there's more data here?
No.
Or this short, very shorter space is less data?
No.
No, you've got to brainwash yourself to always remember that this is 25%, 25%, 25%. So then why is the one wider than the other? That's exactly why. It's wider spread. There's still 3 or 4 data pieces in there, 2, or whatever the case may be, or 2.5, 2.5. The same number of data, but the data values are more wider spread. That's what this is all about. Now, this might not be the best of examples, but for the skewness of the data, because normally we talk about, let's say, if your little boxy there is like Well, I know it's just made skew now. I'm trying to make it right in the middle. Then we talk about symmetrical data. Now you'll see that I'm only looking at the box because that's the first thing you will look at. Now if you look at this data, this right hand side looks a little bit bigger than the left hand side. And then it's not always going to be so cut and dry. Normally when we ask you in a test, it'll be the one or the other. Okay, let me explain. So if your little box has a big fat right hand side, we're going to say it's skewed to the right. Or the other word is positively skewed. So guess what happens over here?
Skewed to the left.
Will be skewed to the left or negatively skewed. But then what about something like this? So I'm going to teach you. You always first look at the box. It doesn't look so much skewed, does it? Almost looks the same. But the little whisker is way longer. Then, after you saw that there's not much going on there in the middle with the box, not much that I can see, it's not really skewed. Then you take into account also the whisker, but then it's really going to mean something. So it looked to me like almost it's going to be skewed to the left where the fat one is. Are you with me? But it's not, because they're actually not so much different. Because of the right hand whisker being so large, it's going to be skewed to the right. But you'll have a lot of exercises on that as well.
Okay.
So just to recap, there could be whiskers on top of there. A little bit more, a little bit less. But this one was quite symmetrical, and even the whiskers, there's not much of a difference. We don't go with magnifying glasses and see 1 millimeter difference. There's got to be a clear difference to actually say that the data is skewed. All data is not skewed. They can be symmetrical. So at first we look at the box. So if there's a definite bigger size on the right hand side, you say that it's skewed to the right, or the other word is positively skewed. Skewed to the left or negatively skewed. Now why must you know both of those? Because my question can be, is this positively or negatively skewed? And you only know skewed to the right and left. But now I'm asking positively or negatively. So you've got to know both words to know what I'm asking you. But if I ask you, discuss how skewed this data is, discuss the skewness of the data, then you can write positively or positive to the right. Any which one, doesn't matter. And then if the box is quite the same, but there's a huge difference with the little whisker, then you'll say because of the whisker, it's going to be skewed to the right. Still the right hand side. Okay, then there's another exercise exactly like this one on page 9, 4.3.2 that you're doing for me for homework.